In this video, we're going to talk about one of the most important pieces of linear functions and just math in general, and that is slope. So we'll take a look at the definition, how to interpret it, and then how to find slope from a graph, between 2 points, and from a table. So definition, you can look at it as the steepness and direction that a linear function has, or the real world connection we have is what is the rate of change that is happening. So we denote slope with we use this Greek letter delta. So delta y, or change in y, divided by the change in x. So if we expand that out, that's taking 2 points of a graph. Here's 1 point, x1 and y1. Second point is x2, y2. So we subtract the y values and divide that by the difference between the x values. Another way we can interpret this is to call it rise over run. So that's what we say when we're looking at the graph. So looking at rise over run from a graph, if we have 2 points here on our graph, so we have 1, 1, and 4, 3, the rise is how much we go up or down from one point to the next along our y-axis. Notice that when we go up, that's the positive direction. When we go down, that's the negative direction. And then the run is how much we run to the right or left along our x-axis. So to the right is positive, to the left is negative. So in this case, from this point 1, 1 to this point 4, 3, we can see we go up 2, so 2 in the positive direction, and to the right 3, so 3 in the positive direction. So that would be a positive 2 divided by positive 3, so 2 over 3. So that's how you can look at it from a graph, thinking about rise over run. If we continue this rate of change should remain the same. Let's see if I can, Let's see if I can duplicate this. My arrows here. So if I duplicate that, if I go up 2 and over 3 again, that gets me to this point here, which is another point on my graph. So this rate of change is constant throughout my entire line. So I go up 2 over 3, up 2 over 3. I could also go from 4, 3 to 1, 1. So that would be down 2 and left 3. So down is negative, left is negative. So that would be a negative 2 divided by negative 3. But we know that negative divided by negative is a positive. So we still end up with the same rate of change of 2 over 3. Now if we think about this difference in y over difference in x, which we're going to talk about here in the next slide, we're taking the y values and subtracting that. So taking the x value, subtracting that down below, and that gives us the same value, 2 over 3. So let's look at another example with that. So we want to find the slope from this point, 5, 1, to this point, negative 3, 4. So I can label this first point as x1, y1, and this second point is x2, y2. So I know what to plug in to my formula. So remember, we're subtracting the y's on top. So we would start with y2 minus y1, 4 minus 1. And, I went the other way, which is totally fine. It actually doesn't matter which of these points is x1, y1, and which one is x2, y2. So I actually, I can't flip it. I had these flipped around for this first one. So I did 1 minus 4 divided by 5 minus a negative 3. Remember, if we subtract a negative, that's the same as adding it. So this is actually plus 3. So we end up with negative 3 over 8. Now let's look at it the way I initially labeled it here. So if we had 4 minus 1 and negative 3 minus 5. So we think that could be a different answer, but then we get a positive 3 over negative 8. And we don't really want to write the negative in the denominator. We want to write it up in the numerator or out front. But both cases end up with a slope of negative 3 over 8. So again, it doesn't matter here, just as long as if you pick this y value first on the top, then this x value that's in the same point has to go with it. So you see 5, 1 go together here first. Over here, 5 and 1 go together second. Last example here is the table. This is kind of similar to the graph. We're just counting from one point to the next. So if we just look at the first 2 points, we're going up 2 for x and down 1 for y. But I have to remember that it's rise over run, so the y over the x. So that is a slope from the first point to the second point of -1 over 2. And let's just double check that that's the same throughout. Up 2, down 1, down 1. So they all have a slope from from one point to the next of -1 over 2. Over here, I notice that I again go up 2 along the x values, and I go up 4 for all my y values. So again, rise over run, 4 over 2. And I can simplify that to be equal to just a slope of 2.